I was at a small conference of web developers, and a recruiter, who's also sort of a friend of mine, said he wanted to do something more with community, get developers interested in their company, and he wanted to do a sort of a meetup thing. And he asked me, do you know anybody who could do a talk? And I was like, well, I like hearing myself talk, so I could do a talk. And he asked, well, what would you like to do a talk about? And I was getting pretty drunk, and I was like, backend, frontend, scalability, WebSockets, so didn't think of it. And then he sent out a mailing to all his clients and all his developers on his mailing list. Jan Brouwer is going to do a talk on backend frontend architecture, scalability, and WebSockets. So I thought, oh shit, now I'm going to have to do a talk. So, well, what is this? This is Internet of Shit, really. So, toilets. I'm just going to do a talk with every slide being about toilets that I put in, except for the first one, which has my face. So, my name is Jan Brouwer. I've been a professional developer since 2001. Before that, I was just a hobby developer. I started out doing C++ and some sysadmining. Then I started doing PHP, which is, well, it's easy money compared to doing C++ and sysadmining. So then later on, some Node.js. I currently work for Node Protocol, which is really boring. Next. So, this talk is going to be mostly language agnostic, except for JavaScript, which is kind of the only language on the web, at least on the front end, because that's the only thing that works in every browser. It's going to mostly be architecture focused and for anybody who likes to do anything, and I would like to also think that the talk is fun. So what kind of applications do people make? What kind of websites? Mostly it's about content, because, well, why else would you do a website content? Some other websites have real-time data-driven stuff that can be physical data, news, chat, whatever, interactive, up-to-date things. And, well, that's it, but when you're doing websites, most of the time, especially professionally, most of the time you're making CMSs of any kind, because, well, content can be anything. So, let's see. Oh, yeah. Back in the olden days, everything was static. It was either just HTML pictures, that kind of stuff, or interactive websites would just be, you send a request, you get something back. You send a request, you get something back. But, yes, that was what I was just saying. But these days, the server side of the code is getting smaller and smaller, and more of the stuff is happening in the front end. Even though a normal website these days is about as big as Doom was when it was first released in the browser, the code is getting a lot more complex as well. That's running in the browser, in the front end, and the backend code is getting smaller and smaller, and everything runs through APIs. And so, scalability. What is scalability? Is putting more hardware, is that scalability? Is using CDNs? But then you have a problem. You need to handle state, because if you scale it up with more machines, you're going to have to somehow maintain state between those requests, and that gets harder and harder the more you get there. So you have to think about different models and performance. But what is performance? Performance is like this, like a Japanese toilet, like a very big, expensive server. But these days, most of the time, that's not what you need. You need scalability. If you have an event like this, it's more used to just put a couple of Dixies down than to have expensive Japanese self-cleaning toilets. And I think it's the same with servers and computers, building stuff. So, what are we talking about with high availability? Failovers, handovers, but how do you achieve that? And how do you get the state in? Or is it better to just get rid of the state and use different models and paradigms? Because I think most of the time you really don't want to update everything and know everything about your client. Let's see. Oh, yeah. Back in the olden days, if you wanted to do something that has automatic updates, you would probably put in an iframe with a refresh in the header, and that would just reload. Or if you wanted to do a chat app in a web browser, you had to do polling and just see, is there something new? Is there something new? Hello, I'm user Amian. Is there something new? That's very interesting. But WebSockets, which have been standardized since 2011, so that's 5 years already, are really nice and can be implemented in most programming languages in the back. Yes, even PHP. How do they work? The first thing you do, you have a client, you have a server, and unfortunately color of the dark gray on black doesn't really work. The first step is a normal HTTP handshake, and then you do an upgrade request, HTTP upgrade, which is one of the more uncommon HTTP requests. You have put, get, all those, post, which are used, but there's also an upgrade request, and you can ask, can I do an upgrade? Yes, you can, and have a stream. And instead of polling, you can do the long polling, the read way with WebSockets. And they're nice for things like chat and game, but serious applications, can you do serious applications with WebSockets? I think you can, and most of us already use them. For example, Etherpad, Ethercalc, the multiplayer Notepad, and multiplayer Excel. And a good example, I think, is Google Docs, which is completely like that. But how do I apply it to my CMS? And what about state? WebSockets have inherent state, because once you connect, it's your session, and you don't have to, with every request, send out a state request, see what's going on. But if you're used to making a standardized CMS, which is just fields which you post with a session key, that kind of stuff, you really need a different pattern to get that working, a different paradigm. And I think the best way of doing that is by using a pub/sub system. There are many pub/sub systems. Pub/sub means publish, subscribe. Yeah, it does literally what it says. And it's very modern, very new. It was first described in 1987 in SOSP conference, and I forgot what the name SOSP stood for. But it's part, then it became part of the news subsystem of the ISIS toolkit, which is something completely different from the ISIS you know. It was one of the pre-standardized browser things. It was, I think, based on Gopher, as far, if I can remember. And it's not a standard, it's just a pattern. Currently they're working on making it a actual standard, and that's going to be WAMP. And again, that's not the WAMP you might know, Windows, Apache, MySQL, PHP, but Web Application Messaging Protocol. It's currently in draft, and I hope it comes out soon, because that would save me a lot of issues. What is pub/sub? The dull part, yeah. So, how does it work? You publish things to a channel, sometimes called a topic, because, as I said, it's not a standard with a paradigm. Most implementations then return a number of subscribers. So you publish to a channel, for example, hello, I'm Jan, and it says, there's 13, 15, I don't know how many people listening. And that's what it does on the publishing side. So, subscription. You subscribe to one or more channels. For example, the talk room. And then you get nothing back. You just wait. You can also subscribe to a pattern, news dot whatever, so local, Luxembourg, Netherlands, whatever. Some server systems that implement pub/sub, the most well-known ones are Fay, Rabbit, MQ, and Redis. There might be more, there are more, but those are the ones I've tried. But now, how are we going to tie it all together? What is it good for? Well, in my opinion, nearly everything. For example, if you have a simple CMS with a user list, and you're working together with some co-workers, well, here at an event, for example, you have a list of users and you set them to, they have registered, whatever. In an older style application, you would have to reload the page to see if there have been any changes. Or you set a timer for that, or you do a long poll or whatever. Since you're subscribing to that list, your first request is just get the whole list. And then you subscribe to the channel of that list. Whenever someone else does something, it is instantly updated on your side, which makes it a lot easier. And you can use that for any kind of widget, not just the nice dashboardy things like you saw here at the dashboard.hexagreen, but for anything. You can also subscribe to alerts. For example, someone logged in, bling, have a nice pop-up, and working together. So any table could be an automatic updating list, even with pagination and anything, which is sometimes very hard to do with a long updating list. But if you do it via PubSub, you get all the stuff, and it's just what do you display? And you only get the changes, so it's naturally a very low server load. It reduces the server load, it reduces the bandwidth used, because you're only getting changes sent through. Also subscribing to any data channel. No idea where I was going with this. But here's the interesting part. Any form can be a multiplayer form. So if you, for example, have a CMS, a standard, whatever, WordPress, whatever you like using, you have a couple of fields. And if you and a coworker together are working on it, you have to kind of make agreements or do locking and say this page is locked, this node is locked, whatever. Or you get corruption because two people are changing stuff on the same time. If you do the PubSub way of doing things, you can, for example, as soon as with your mouse or with your tablet, you click on a text field, to all the other users of that page, you can send, ooh, this field is now locked. It will be read-only in the client, and you can't get data corruption because you're working together in real time, which is nice. So how does that work? You, the client, your client, sends an event to an API, which is just whatever you like to code it in Python or in PHP or C++, whatever fancy you're about. The server then broadcasts your change to a channel. It doesn't even matter if nobody's listening, it just gets broadcast to the channel. And the other clients who might be listening, for example, because they're also editing that page, they get those changes. So it's very light for the clients, and it's very light for you, because you're only sending the changes you do, and only people who are subscribed receive those changes. So how do we implement that? Personally, I really like Redis, so I would advise to use Redis as a messaging bus system on your system, which on most servers is just a one-click install, apt-get install Redis, and it barely needs any configuration to run out of the box because normally it only listens to local hosts, so firewall rules aren't needed, and mostly your firewall blocks anything anyway because you're only opening ports for stuff you need. Then you could do Node.js or some other socket server which people connect to do the actual talking to Redis. I wouldn't advise to ever open up Redis itself to the end users, but to have a simple socket server. And I have done this, for example, for a major Dutch insurance company. They wanted a chat app for patients, or well, not really patients, but people to, instead of going to their local practitioner for very small things, to just be able to chat with the nurse, including video chat and all that stuff. And the Node.js server we wrote for that is at, I think, 45 lines of code, like literally 45 lines of code to do the in-between handling of those requests. What? I have no idea. Oh yeah, why not just do the backend? You already have a backend probably because you want to retrofit this on something. And the nice thing is it's very easy to retrofit because you can do it with small parts. You just start with one widget, one channel, and just slowly add more stuff. And you don't have to edit in multiple locations, only in the real front-end code and the real back-end code, just as you would with any of those kinds of changes, like adding a field or whatever. You still need a database because the pub/sub mechanism itself doesn't store anything except for example, a log or of access or that kind of stuff. But you will still need a database for the actual data store. And if you use Redis, it has some very interesting extra perks. For example, it's also a key value store with a time to live. So if you want to have API rate limiting and you have a distributed system, that would normally be a hard problem. With a key value store that is shared amongst those servers anyway, with a time to live key value store system, it's 5 lines of code to do rate limiting. You just have to add a new record for any API call, and then you can check just the number of records already in there with the same IP, for example, and they will fall out of the store anyway because of their time to live. Super easy. Redis also does partitioning, so you can have it run over multiple machines without having to have all the data on all the machines, which is nice. It can do distributed logs, auto eviction, cache store, whatever you want. It has very, very many features. And it allows Lua scripting on the back end, which for some people might be interesting, for others might be very scary. On the front end, I would advise RxJS or Angular, but any JavaScript framework would work. You can have listening data objects, which are automatically updated. So again, very few lines of code are needed, because you just subscribe to the channel and any changes are just changes to your existing data model, which is very easy to implement. With React, you have to do something Flux, because I have tried to use React and I still don't understand shit about it. Again, Flux is also not a library or a thing, but it's a pattern, it's not a system. And Redux seems to work. I've heard it, I've never gotten it to work myself, but I'm not a front-end person, so I don't care. There's also pub/sub.js, which is really small, really fun. If you want to do a small project and use something with a pub/sub mechanism, for example, make a simple multiplayer game or anything, I would say just go and play with pub/sub.js. It's really fun. Can be done in a day. But then that question, will it scale? Subscribers are cheap, as I said. Once you a subscription is just like a simple API call, just saying, hello, here I am, and that's it. That's all the bandwidth that's needed. Also, load balancing is way simplified, because you just have to get the Redis cluster to work, which is very simple. It's auto communicating. I forgot the exact words, the exact name, but it's very easy to set up. And you can have a very easily scaling cluster of machines, because all it needs is that, as I said, in our example, it was 45 lines of Node.js code and a Redis instance, and you're set. And for the API, the same thing goes, because it's just your standard code base. However you would deploy that, all it has to be able to do is communicate with the Redis server. A single Redis server can, for example, we tried that with a couple of games, easily take 10,000 users that normally do approximately 1 or 2 requests per second. So in the tens of thousands of requests per second is not a problem on a very, very small, it was a 1-core VPS, so it's super easy to roll out and load balance. Because, yeah, the easiest round-robin setups just work. Requests are lighter, less data, because you only get the changes, you don't repeatedly get all the data of from the database. It's also easy to add, as I said before, and it works very, very well with auto-scaling, because the inherit state makes sure that if a client dies, you just have to reconnect and everything works again. Super easy. That's what I said. Oh yeah, also you will know when the socket closes, so you can actually trigger on people going out. So if you have a number of visitors or something, it will be up to date, because as soon as you close your browser, the WebSocket will be notified that the connection is closed. And that works very easily again. But what about security? That's interesting. WSS or WebSocket Secure is mandatory when you're serving pages over HTTPS, otherwise you get the cross-content stuff, and it's exactly that. It's just WebSockets over SSL, same as with HTTPS. Super easy to set up, and because it normally runs on port 443 as well, it's completely compatible with Let's Encrypt and all that stuff. Super easy to set up again. JSON Web Tokens? Why would you use that? Well, but it's at least as safe as session cookies, because it's just a token. And the subscriptions, as I said, are dropped when the connection closes, so that's a lot safer than token-based systems, because as soon as your connection drops and you try to reconnect, you have to re-authenticate instead of being able to reuse your session token like normal. It's very unit testable. You can set up an echo service in minutes and do simple tests with and unit tests. And yeah, especially if you bolt it on, or anyway, the first request you do to the API is normally just a GET request. So even if, for example, you have clients that don't support JavaScript, it's just an add-on. It's just taking away some convenience, but it's very, yeah, it's easy to do graceful degradation. And you have a ledger for accountability, which is built into all the PubSub mechanisms. So you can do accounting and auditing in a very straightforward way. Retrofitting, yes, fitting PubSub. As I said, it's very easy to start small. If you have a website or a project or a program or anything that's not a wiki, because it's pretty hard to do with a wiki, that's probably a rewrite would be better. You can just start changing your widgets into automatically updating widgets, into smart widgets. And then you can go and async all the things. Well, this I already explained, things fall into place. You first get just a page reload, you get all the data, and you register to that channel, and then you get the relative changes. Wrapping up. Every web browser currently supports this, literally everyone. Over 95% browser supports complete bullshit, because who uses Internet Explorer 9? Anybody's client still using Internet Explorer 9? And also, and the same goes for Android 2 point something. Android 2 doesn't really support this well. So, any questions?
Yeah.
Yes.
So you initially showed scaling by having multiple instances of a server. How does that work here?
Multiple servers?
Yeah, multiple server frontends, if you will.
Yes, that works, like HR.
But shouldn't they now be bound in some way?
That is what the Redis does for you. Redis has this auto... it's like a bonjour protocol. It's just as long as they have a shared key, they can connect to each other, or when they're in a VLAN or whatever. That's a one-time setup, and then they will communicate together. And in most of the cases, you don't need multiple Redis instances or RabbitMQ or whatever you're using as a PubSub mechanism. Just multiple front ends for the actual connecting to the end users, because those socket connections, they stack up, and that you might want to load balance or something, and you probably won't even need a multiple Redis or RabbitMQ or whatever the PubSub system is you're using backend. You can do that, and they do have auto discovery, which was the word I was looking for. So that's pretty easy to set up. There is, I think, even an AWS package in their big fat interface of all the things you can click together that does it for you.
Is there also something by way of failover? So you as a client are connected to server 1.
Reconnecting there because there is no there is no data there is no real stack of stateful things that have to be negotiated again. So it's just reconnect to the next one and you're all set to go again. Because you're just waiting for changes. You're listening for published stuff on your subscription. So there is the failing over is as easy as just reconnecting. Okay. Well, in that case, I would like to thank you for your attention again.